Good afternoon, 7th graders. Today we're working on lesson 7.1.2, scaling quantities. Make sure that you've had your homework checked by your teacher and you have your book open to lesson 7.1.2. I don't have the page filled in for you, sorry. So find that for yourself, and then when you're all ready and you have your title written, you can press play and we'll start the first problem. 7.1.2, how can I make it smaller or bigger? Scaling quantities. In Chapter 5, you learned how to find the percent of a number by making a diagram to relate the part to the whole and find the desired proportion. This calculation is fairly straightforward if the percent is a multiple of 10, like 40, or it can be thought of as a fraction like 1/4 equals 25%. However, it can be more challenging if the percent is something like 6.3% or 84.5%. So this is when you use the number line and it went from 0% to 100%, and then you had some whole that you had to break up into 10%. And that was a lot easier, but today we're going to be talking about when it's not a whole percent that can be broken up into tens. Today you will connect what you have learned previously about the relationship between distance, rate, and time to the idea of scale factors. You will learn how to use a scale factor to find the corresponding lengths of similar figures. This idea will add a powerful new tool to your collection of problem-solving strategies that will help you to calculate percents. The first problem we're going to do together is 7/16, so you can write that in your notebook. Dana is training for a bicycle race. He can ride his bike 25 miles per hour. I can ride way faster though. One day, when he had been riding for 3/5 of an hour, he had to stop and fix a flat tire. How many miles had he ridden when he stopped? The diagram below may be useful. So hopefully this looks familiar to what we had done back in chapter 5, where I talked about it went from 0% to 100%, but now we're going from 0 minutes up to 1 hour, and then this would be 0 miles to 25 miles. So the first thing I'd like you to do is start by drawing the same diagram in your notebook. Okay, so the goal here is I need to find in 3/5 of an hour how far he had gone when he had to stop and fix a flat tire. So if I have 25 miles as my whole and I have my hour broken up into fifths, I will also break my miles up into fifths. So I have 1/5, 2/5, 3/5, 4/5, 5/5. So if I divide 25 into 5 parts, be 25 divided by 5, that would be 5. So in each of my parts here is 5 miles. So I'm splitting up my whole of 25 miles into fifths. And then this makes it easier for me to find how much 3/5 of 25 miles is. So it looks like I have 1/5 is 5, 10, 15. So this would be 15 miles. And MI is the abbreviation for miles. So to answer my question, I'm going to write a sentence. My question is, how many miles had he ridden when he stopped? The way I'd answer this is he had ridden 15 miles. So that's what your work and your answer should look like in your notebook for 7/16. Okay, so we're doing the same thing as percents, only it's not percents this time, it's some different whole that we're breaking up, but using the same type of number line to help us. 7/17 is the next problem you can write in your notebook. It says Matt thought about problem 7/16 and drew the diagram at right. Look at Matt's drawing and decide how he is thinking about this problem. So if I look at the problem, he has decided to draw 25 into a triangle, and he's saying that this side of the triangle is equal to 25 miles. And then he's going to take a part of it. So remember, multiplication means of. So he's going to take 3/5 of that 25 miles, and that's my x. Because we want to know what 3/5 of 25 is, and that's our missing amount that we wanted to find, so he labeled it x. So here it says write an equation that uses the scale factor to find x. In this case, the scale factor is 3/5. When we've done this before, it's usually been whole numbers. Somehow we're getting from one figure to another using a whole number. Here we're going to be using a fraction. So my equation would be, the thing we're trying to find is x. So I'm going to have x equals, and it looks like x equals 25 times 3/5, and that's going to give us how far he had ridden. So x equals 25 times 3/5. So that is essentially what we did here, because we did 3/5 of 25 miles. 1, 2, 3/5 was 15. Here, this is the same thing. 25 times 3/5. That's 3/5 of, multiplication means of, 25 miles. B says, what connection is Matt making between finding a distance using the rate and time, as you did in problem 716, and using a scale factor with similar figures? How are the situations alike, and how are they different? So I have to relate this to distance, rate, and time. So I'm trying to find the distance he had traveled. That was my question. So dx is the same as d, which is distance. That's the thing we're trying to find. The rate, so I have distance. Rate is how fast he was going. So rate is the 25 miles that he can travel in 1 hour, times 3/5 is the time, because he travels for 3/5, I want to write time, 3/5 of an hour, so that's related to time. So when we talked about distance, rate, and time in the last lesson, we came up with the equation distance equals rate times time, and this equation is always true. So we did the same thing here, only we had filled in distance with x, rate with our number of 25, how fast he goes, and time of 3/5, because that's what they told us how long he had been riding for. So this is an important equation that you need to make sure that you have written down. Okay, you're going to try scaling quantities on your own. So you're going to do problems 718 and 719. Once you can show your teacher you're finished with those, then you have homework tonight, which is 21 through 26. Good luck, and let your teacher know if you have any questions.